What's up, guys? It's the Rabbit here, back with another video. I'm getting started on a little bit of work on the old Magnavox here. Now, the last video we looked it over, just checking it out, make sure everything's tip-top. I've already removed the screws for this to get this started. Tonight, what I plan on doing is installing these pins for the transistors. Now, the only transistors that are being installed with them are the amp transistors. I'm not putting the outputs on anything. They're fine how they are. Plus, it would take way longer to do. Hopefully, I can make this a fairly quick video. My tool just came in today. If you guys don't know what one of these is, this here is a speed tool. It's a gauge. Now, you have 3 different setups on here. I mean, it looks like there's more, but there's actually only 3. 78, 33, and 45. You got 60 cycle hertz, which is US, and you have 50, which is a UK. So this can work on either machine. One's from the UK, one's from US. That's how many hertz of the frequency coming through the outlet, because electricity flows in a frequency. This here judges your speed. The goal with this is when the turntable's running, whichever one you want, 33, 45, 78, whatever you have it set on, you look at that, and what you want is it to appear like it's a continuous line. If it looks like you can see the little lines and it's kind of off-centered and they're moving, you can see them individually, then it's going too fast or too slow. If it looks like it's becoming a continuous line, then it's going the correct speed, which thankfully this machine is going the correct speed, but just figured I'd point that out. These are really nice to have. I ordered this off eBay the other day, a couple dollars. As I said before, there is a needle on the way for this machine. One eye is from the other machine. We will check that machine out later. But right now, let's get started on the amp. Put y'all on the tripod here. Not a half bad tripod either. Bought it when I bought the camera. Okay, now you guys are all situated. Again, sorry off balance. It's halfway on the bed. But either way, let's get started on this. Better plug my soldering iron in. Always important to have. Be careful when using soldering iron. They do get pretty damn hot. Now this machine's plugged in. Please work on these machines when they're unplugged, unless you absolutely know what you're doing. Just simply going to disconnect everything here and get the machine out of the way. That way I can actually do the work on the amp. Another good important tool to have. I have made this myself. You can make them just out of simple hardware parts at your local hardware store. Get yourself an extension cord, some light bulbs, some light sockets, an outlet, and a switch. This is pretty useful to have if you don't have a Variac. What this is a dim bulb unit. What it does is it works like a fuse. You put this in series with the machine in case if there's any problems with the machine before you do any work on it. When you plug it in, what you want is something that'll act like a fuse. This does not work with LED bulbs. It does not work with fluorescent bulbs, only incandescent. Only use incandescent bulbs. Use any of those other ones, you're just going to blow shit up. I have a 15 watt and a 40 watt here. What I do is I plug this in, and the way that this is set up is one wire, the hot wire, which is your positive lead here, then your ground wire here, your negative, Power comes in here, goes through the switch, in one side of the outlet, which goes through the bulb, out the other side of the bulb, out, and to here. The other wire, the neutral side, is directly connected straight to the outlet. So I have this hot side switched, and that runs through the light bulb. Now, light bulbs here, they act like a fuse. This is why you use condensate, because the condensate will pop. Fluorescent will burn up, and so will an LED. What the light bulb does is it draws some of that current off. If there is a short in the unit, the machine you're testing, TV, radio, stereo, whatever, this will come bright on, and that's what you don't want. That's why you also use something like a 40, 60, 100 watt, depending on the wattage that your machine is. I like to go lower, that way it's less voltage. What it's doing is it's current restricting. It's not giving the device full power. It's limiting it. What I'll do, I go the safety way, what I'll do is I'll put the highest watt bulb first, turn on. What you want is the bulb to light up, not real bright, but bright, and then quickly dim down. If it's a tube equipment, it'll light up, it'll dim down, and then it'll start to barely glow because the tubes are now conducting. If there's a problem with the machine, however, the light will come straight on. If there's a major problem with the machine, the light will blow. And it'll pop like a fuse. Okay, now what I'll do is I'll use the highest watt first. If everything powers up and runs fine, at that point I'll switch over to a lower watt bulb. If it's still working fine, I'll use both bulbs. Then after that point, I will take the unit, completely unplug it from this, and plug it directly into the line, which is directly into the outlet. And the best part here is I can have the machine turned on using this device. I can have the machine turned on, but no power going to the machine until I flip the switch. Just in case if sparks fly, you're at a safe distance from it. If those don't happen to blow right away. Flip on, flip off, you know, basic shit. Really easy to use. Again, you take an extension cord, you cut the hot lead, use a ohm meter with its diode checker to figure out which end is which on the actual wire here, and cut that particular wire, stitch an outlet, a switch into place, connect that, connect the outlet on that line as well, a little further up or down, wherever, and then you got 3 plugs there on the ends. Or if you have a variac, you can use that. And that's even better than a dim bulb because you can choose voltages on that. So, just a note there. One of those is a really good, useful tool. Very usable. Saved my butt a few times, that's for damn sure. I'm gonna lower y'all down here a little bit. Now the transistors I'm going to be socketing are these two, and these two. Pretty simple. Desolder them on the back, pull them off, put pins in their place, and then stick them back in. Make sure you put your transistors in correct, because if you don't, you'll dead short them. And not only damage that transistor, but possibly blow out the rest of the transistors on the board. You don't want to have to be replacing all the transistors. Especially on something vintage like this, they can become a pain in the ass to find. I've already lined up my 3s for each transistor. So, it's a pretty simple technique. Just going to find the transistor and remove it. Let's see. Usually what I'll do most of the time is I get the pins ready. Try and give them a little fresh solder. Once I find that transistor. Let's see, where was it? It's right there. And at the same time, you can always go through and touch up some solder joints if you need to. Always be careful while doing this kind of stuff. Try to get rid of as much excess solder as you can. There are solder removal tools out there. Unfortunately, at the moment, I just don't happen to have one. You use solder wick. There's multiple different things you can use. There's a solder sucker out there. Always want to make sure I got my base collector emitter going in the correct way. And if you're careful enough, you can actually take the transistor out in such a way where the terminals stay in position. Where you can easily just stick them right back in. Now what I'm doing is using the soldering iron to remove any extra solder on the pins that may get in the way. Be very careful. But that may get in the way of the sockets going on properly. You gotta be real careful with this stuff. It's delicate. And if you're not careful enough, bad things are bound to happen. Oh, there's still a little bit of solder on that one. Now, with those sockets on there, it's like a plug. Now all I gotta do is solder these pins straight to the system. Then if ever this transistor blows out, I can just pop it out of circuit, easily test it or whatever needs to be done, and replace it if need be. You see those things moving there, maybe can't. Those are now what I'm going to solder. So I get one anchored, if anything. A little solder on the iron here, try to get one anchor to it. Little tip, you don't want to hold the solder to the unit too long. The iron on the board, because if you do, you could burn the glue that holds the traces on, and the traces will start coming off the board. And that's never a good thing. So we'll bring you all in here a little closer. Trying to do this on camera and see what I'm doing at the same time. So I'm off to the side of the camera. You don't need too much solder either. You only need a little bit. There, now that one's complete. Yes, it'll stick off the board slightly further, but at least now, if it blows out, all you gotta do is remove it. Boom. Done. I've already done this to the other unit. I don't know if you can see those, but there's the little pins. B stands for base, C stands for collector, and E stands for emitter. The base is like the switch to turn on and off the transistor. The emitter picks up the signal, and then the collector there distributes the signal. It collects it and sends it out amplified. The sockets push right back in. They're slightly tight, but that's normal. You want them to be kind of tight, because if they're not, then it falls out, makes bad connection, so on and so forth. Those are things you just don't want. You always want good connections. Good solder points, good connections. You can clean up the flux off there with a little rubbing alcohol, Q-tip, all that. At the moment I'm not too concerned with it, because I just want to get these transistors taken care of first. I'll probably do that later. It's not that big of a deal. Now you just want to take your time at this stuff. There's never any rush. Just carefully keep heat on the pins simultaneously. Just enough to get the component out. These transistors here, these are the guys that do all the work in the system, by the way. Little solder there just does not want to come off that pin. There we go. Now, yes, you can hook these up backwards and wrong and all kinds of shit. Don't do that. I cannot stress enough why not to do that. Because one transistor can blow out all the others if it dead shorts. Whether by electrical malfunction or because being hooked up backwards or wrong. Solid state technology, man. You really cannot arc this stuff. You can't hook it up wrong. Can't do none of that. Because if you do, bad things happen. Sometimes bad things happen to where you can't fix it. That's not a good thing. Obvious reasons. Kind of bent that wire, but that should bend right back into place. Be careful with these wires too. They're very sensitive. All these components can be very sensitive. Now, I already did this with one machine. I'm not saying I'm an expert at it. I mean, I'm really good at what I do, but it's a lot easier to have these holes open too. Take your time at this stuff. You're careful enough. You can get this stuff fixed up pretty damn well. Basically what this is this ain't a necessarily need thing here, but I like to have my parts able to be exchanged real easily, get fixed easily, depending on what machine it is. So, I'm not saying you have to do this for all the machines you fix or work on. It's not that big of a deal. See if I can't get some more light here. That's better. And they don't have to be perfectly placed, as long as they're connected properly and well connected. That's 2. Now we got 4 more. Always be careful moving components out of the way. Now, if you're not sure what these things here are, these big long things, I know they kind of look like one of those early microchips, but they're not. They're known as couplets. And what that is, and no, not couplets, couplets. What that is a series of capacitors and resistors inside of here. They're one of the first forms of an integrated type circuit. You may come across a lot of those. Now finding schematics on those can be pretty damn difficult. I guess it all depends on what the machine is and how it works and how many of them they got. Those you can build a setup of capacitors and resistors if you can figure out what the values are and if you can find a way of mounting them into the unit, which yes can be very difficult. It just depends on if you can figure out what the values are in there, because every component has a value to it. You gotta have your values right. I mean, they say you can go a little more or less on capacitors depending on what its job is in the system, and they're true. That's right on that. But you really should have the proper value that the machine requires, just to be on the safe side, you know. Sometimes you gotta stick in what you got. But again, it depends on what that circuit plays role in the system. There can be circuits in some systems that aren't even required, but they're there. But everything's there for a reason. So that's why having a schematic really comes in handy. In this case, I do not have a schematic, but I've worked on this make and model so many times, I pretty much know it for the most part. So it's actually not too hard for me. For some of you beginners out there, it might be difficult. Not everybody is in the same situation. Sorry if I'm getting off camera. I'm just kind of off to the side here and trying to get as much in view of camera as possible. Once you understand the basics of this stuff, though, it's actually pretty easy to work on. Now, sometimes when you're working on this old stuff, you'll come across solder points that look something like this, where they're open. That's bad. Now, as you can see, that's what I just did. But you don't want them open like that, because then what they do is they have a tendency of breaking. Either break at the trace or the lead breaks off, and then it causes a short connection. That's what I mean when I say look over the boards for cracked solder joints, broken solder joints, things of that nature. You want a nice full solder joint. Because if you don't have a full solder joint, you don't have a good connection, and you have problems with the machine. You can take all day chasing down problems, chasing ghosts down, and can't find shit wrong with it. And that's why. So you always want to make sure you got a nice, clean solder joint. Sometimes it's easier to tin your soldering iron first. Other times, most of the time, the way you should solder is you take the solder, you place it to the pad, and then you put the iron on it. And there you go. You only need a little bit. Get yourself a very nice solder joint there. Again, this is the filter cap, so it's not a big deal. Solder. Heat the pad. It's a pretty simple process. You need enough just to cover the whole pad. You just go over it with some rubbing alcohol. It's quite simple. This stuff can be real easy to work with. If you understand the basics of it, it can be very easy to work with. Thankfully, a good thing about Magnavox systems, because not all machines are going to be like this, but thankfully, a good thing about a lot of Magnavox systems is they have the stuff labeled. The resistors, the capacitors, transistors, diodes, they have it all labeled, as you see on this board. They have it all labeled here. I don't know how well that's showing up on camera, but all this. Like that right there, that R132 is a resistor. That C128 is a capacitor. That would be this one right here. The resistor there. Transistors, base, collector, emitter. Another good thing about these units is they have the same on the opposite side. So they got the imprint and they got all that. Most machines will not. Some will have their numbers on the one side, but they won't have anything on the back side. So most will not do that. Just always check. It always comes in handy to actually have them put that. Now Magnavox, like I said, is one of those companies that do that. I don't know how well they do on modern stuff. I don't even know how much they make nowadays. But you just carefully work it out of there. Work it loose. You don't want to keep the heat on not only the board too long, but you also don't want to keep the heat on the component too long either. No matter what the component is, you don't want to do it, because the heat itself can do damage. Though these machines can handle quite a bit of heat, you can still do damage with it. I happen to be using a 40-watt soldering iron. The higher the wattage, the hotter it is. Just saying. It's pretty simple work. Now these traces, like I said, are very delicate. And they can peel off the board real easily. Trying to open these holes, I'm probably not going to have luck here. So I may have to hold this one as I push it through. Well, worth a shot, right? Now the way this amplifier is built, which is a lot of these amps, they are two identical amplifiers in one, making your stereo sound. The channel splits off from left to right. And make sure it's seated correctly. Well, let's be gentle with this stuff. Almost had a bridge connection there. That would not have been good. Would have blown up. Now everything should be hooked up correctly. I still got these last two to do. These guys are going to be a little more difficult because of their location next to this couplet. But it's okay, we can knock this out. Sometimes this stuff looks pretty intimidating, but it's actually quite easy. These are crucial too. I should point these out on these kind of metal capped transistors. These little tiny pins, I don't know if you can see that very well, but these little pins sticking off, they usually indicate directionality of the unit. In this case, the pin's standing for the emitter. So there's the E down there. I don't know what you can see that there. There's the E. There's the pin. The little key. Again, E, key. Tell you, this lead right here is the emitter. I'll tin both while I'm at it. That way I just bounce them both out. These are both identical transistors, so other than positioning them correctly in the circuit, they can go in either spot, these two, because they're both identical. They're twin pair. That would be the same with the outputs. They are twin pairs each. And this system is set up in a push-pull deal. So one transistor turns on when the signal turns positive, then turns off when it turns negative, and the other one turns on when it turns negative and turns off when it turns positive, the signal. They push-pull to drive the speaker in and out. So I have two sets here. It's a push-pull amplifier. One channel, second channel, on, off, back and forth. They oscillate back and forth with it. Pretty nifty how they work. You have two forms of transistors as well. I don't know if you know this out there or not, but there are two kinds of transistors. Most modern shit all runs with silicon transistors, but you have, especially this older stuff, like to work with a lot of germanium. It's a type of crystal. Both silicon and germanium are crystals. You have germanium transistors and you have silicon transistors. Depends on what you're working with. This one's case, these are probably silicon, but it's possible that they could be germanium too. Sometimes you have a mix of both, or it's a system that has both kinds, but not too often. You also have the other deal with them is there's two types of transistors, PNPs and NPNs. So you either have NPN transistors or PNPs or a combination of both in the system. Depends on your system. Now when you get schematics for this stuff, don't freak out when you look at schematics. They're not that complicated. If you've ever checked out a road map for land-wise, it's pretty much the same thing. Think of the wires as roads and the symbols as landmarks. Resistors, capacitors, whatever. You know, as landmarks. There should be a map key, so to speak, which would be a schematic key. It's not the same, but it is the same. It works the same way. Each symbol is whatever. There should be a parts list on the schematic. And the schematic usually tells you, most schematics, some don't, but most schematics do. They'll tell you what the component values are. Some do, some don't though. Don't hold me on that. It just depends on where you get the schematic from. Use this side to anchor one pin in. That way it'll hold it. We have one transistor left to go. See how easy this is? This is pretty easy. Easy work. Ooh, that one slipped right out. Bet you I had a bad connection. Slipped out without even moving much solder. Go figure, huh? Sometimes you come across shit. Bad connection points and stuff. You'd be surprised at what kinds of problems a bad connection point can cause. All kinds of things. Issues with controls, issues with output, issues with processing, depending on what the machine is. Good thing about a lot of this older stuff is you won't find really much to any microchips. It's from the 70's and 80's, you may come across a few. You're going to get into more microchips as you get further into later 70's, earlier 80's, on through into like the 90's, all the way up till today. Whereas you go further back, from like the mid-70's further back, you get less and less microchips. Once you're in the 60's, you really pretty much don't have any microchips for the most part. They're just not there. Whoops, I grabbed the wrong transistor. How funny is that? I desoldered the right one, but I grabbed the wrong one. That's actually comical. Hey, say you stick around, you never know what you'll come across. Even me doing some oopsies. It's okay. You're gonna make mistakes. We all do. That's why they say learn from them. And thanks to that little key, I know which pin goes in where. The R pins align right where they're supposed to. Let's see if I can't get the right transistor out, huh? I'm just glad I soldered on the right one. Otherwise I'd be removing the pins I just put in. Funny how that works. This is no problem. Again, Always take your time with this stuff, because if you start rushing through this stuff, you're going to start making major mistakes. What I just did was a petty mistake. That was nothing. Nothing that would have caused any problems. See if I can't open up one of those holes, huh? Make it just a little easier. I got the emitter open. And that is now done. Make sure it's firmly in there, let it cool for a moment. Now all those are simply socketed. So if one blows up, just unplug it and replace it. Can't say it'll be that easy to find the kind of transistor, but sometimes you can find some pretty damn suitable ones that'll work. Now all that's left is, hopefully, if I got everything correct, which I hope, I put them back in the same way, but never know, accidents happen. It should just power up and play like nothing happened. So, I guess moment of truth. Give me a minute here and I'll get the main unit over here. We'll hook it up, throw a record on there, see if it works. Or something could have gotten hooked up wrong and it'll go bang. Well, that'll be fun too, right? I prefer it not to go bang, but if it goes bang, hey, it's some entertainment for y'all. Shit happens. This particular amplifier requires good 14 volts power, AC. Now, there's two forms of voltages too. You got AC and you got DC. No, not like the band. Though they do good music, not like the band. AC current is alternating current. It is bouncing between positive and negative, back and forth. Okay, through the lines, which is what comes out of your outlet. DC current is direct current. Come on, focus. DC current is direct. And the way that works is it goes directly in one way and out the other of the system. So, the camera's acting weird here. Go figure. Guess the camera's trying to go sleepy time. Later on at some point I will be opening this machine again, and I will be cleaning that switch I was talking about in the first video, because it's going to need it either way. Power, audio in, audio out. Normally I would probably dim bob this, but I'm not too concerned with it. If I plug it in and turn it on, I want to connect the speakers, if anything. That would be helpful. Otherwise we'll hear nothing and not know why. Now, you guys know why. I'll just be running around like a chicken with my head cut off, huh? I can figure that out. There's a short in this speaker here, down in the plug here. This is a common issue you'll find with these. So, it happens. Things get old, they wear out. But these old machines, man, take good care of them, you maintenance them properly, these things will last you forever. New machines, you crank them up, hold them for maybe a couple days, have them cranked to their maximum volume level, and things will kill over in just a few weeks. Not these old things, these things will demand more. They were definitely built to last. Okay, it's now hot, meaning it's got power. Let's see here. Well, good news, it didn't explode. Yeah, I know y'all probably laughing at me. I damn went and hooked the speakers up backwards. Again, I think by now I would have figured out which one goes where. Of course, this doesn't say left or right channel down here. It just says channel 1, channel 2. Good thing for the balance control. Let you know if you got it hooked up right. Turn it that way, it goes left. Turn it that way, it goes right. If you got that side playing when it's going that way, obviously something's wrong. And obviously center top is middle. Again, for copyright issues, I'm not going to play a full record or anything. But I'll play a part. Few seconds of a record. Why not? Bar up's 45, right? Have some sitting over here. There's a good one. Computer just fell. Not a big deal. Still gonna have to oil this a little more than what it is. Kind of tight. Little tip. Here's what will happen if one of these circuits gets removed. Now, you can think of these guys as doing a job, these circuits, the transistors. They each have their own little job. You see it just made noise, kind of hummed. That's just one channel. It was bored. That's what you would get. One channel working. That channel does not. and you get that noise. It's because there's still one transistor running, the other one's not. Main circuit's dead because it's not in the circuit. One way of diagnosing if there's a problem right off the bat. Once it'll be reconnected, signal will come back on and it'll run normal. You see how that went quiet. Again, each circuit does its own job. I may have that in wrong. This particular system's a little weird, but it'll work. Anyways, that'll be it for this one. I'll catch y'all on the next time. I'm going to put this baby back together, play some records. See y'all next time.